Okay then, two videos. The first video, do we need to talk about that one? Not really, I'd be a moron, wouldn't I? Second video, quite interesting. Biomass materials, carbons. Interesting results, actually. I was quite surprised. Maybe you were too. Now, the second video, comments, quite a mixed bag really. Oh, before I forget, I nearly forgot, the video that you're going to see later on is of a new carbon. One of my subscribers, Blues Doctor, quite an intelligent man actually, very well educated, suggested that I try a certain item, carbonise it and try that on a battery, and I have, and the results are after this. Very surprising. So that's a one-off special for you, Blues Doctor. So back to the video then. Really mixed bag of comments, ranging from I'm being too technical, can I slow down a bit, to maybe I'm not technical enough in one respect, can I show more results, energy densities and stuff like that. Not really, because at the end of the day what this is all about now, this section, is I'm trying to find the best of the best of the best of a carbon that comes from a waste material. You know, now that could be a biomass material, it could be any material, anything at all. So that's what I'm trying to do, and I'm trying to find the best carbon I can. Now, we know graphene exists, we know carbon nanotubes exist, and we know what they do, and we know how brilliant they are. But I'm trying to stay away from that. I'm trying to find this carbon, you know, the best of carbon I can get from a biomass material or a waste material, and that's it. So I'm testing that many that I can't really sort of talk, I can't give you any more technical information just yet. When I find, let's say, I don't know, 2 or 3 or 4 or even 5 carbons that I think these are the best, then we'll start talking a bit more technically, and we'll talk about the results and all the rest of it. So I mean, what is my target audience? I personally, I'm an amateur, so maybe my target audience are people like me that are just amateurs, the educated people, the already educated people, the really clever people. I can't teach those people anything. If I came up with something really super duper, they'd be interested obviously, but you know, on a technical level I can't really impress people like that. I'm still learning, you know. I've learned a lot, but I'm still learning, and I'm always willing to learn something new every day. So that's it really. Now, the people that are non-technical, then let me say something to you. When this progresses, you know, when we get onto the real chemistry and stuff like that, I cannot possibly be non-technical. I've got to be technical, and I've got to talk on a technical level. It's the only way forward. It's the only way you can do it. If you look at batteries, anyone that talks about batteries, what's the most common used word? Ions. That is the most common word. Now, I would have to talk about ions, even polyatomic ions, or any type of ion. Not necessarily in a technical way that you can't understand, because I will describe things in a way even the non-technical person could understand, because that's closer to my heart, because I'm an amateur. So the thing is, how could I possibly talk about an ion, let's say a sodium ion, like that, and not discuss where it came from, how it was made, how it was formed. Well, it's simple really. It is really, really simple. When you look at it and digest it, it is really simple. It came from an atom. It's now an ion, and it was an atom, like that. So you've got a sodium atom and a sodium ion. There's not much difference, is there, when you look at it? There's a series of rings there, and they're called shells, valence shells, and if you look at the atom, there's a little red dot with an E on it. Now that's an electron, and what that atom wants to do is lose that electron. I'm not going to get too technical right now and talk about too much, because I want a lot of this in one of my other videos. So that electron in that outer ring, the valence shell, it loses that. They're quite clever atoms. So it loses that, and all of a sudden it's an ion. That's it, simple. So, you know, that's quite technical, isn't it? But it's not, is it? It was simple. And when you look at these things, it is simple to understand. It can get more technical later on, but I won't do that right now. But that is simple. You know, there's an atom of sodium, and there's its ion. Now really all it is, it's got rid of that electron, and it's a bit happier, because the ring, it's now shrunk. It's an ion, and or it was an atom, and it's shrunk. Now it's an ion. So all it's done is given away that electron, and another atom has accepted that electron, taken it like that. Now you're left with another ring with 8 electrons in it, in the outer valence shell. Simple. And it's a lot happier, and that's all I'm going to say, because I'm going to ruin my other video. So, you know, what I'm trying to say to the non-technical people, like me, that is ever so simple, and a lot of it, a lot more of it, it sounds technical, but it is really simple. When you, what's the difference? Oh, I've got to learn this. No, you haven't. You've got to want to learn it. That's the difference. If you want to learn it, it is so simple. So I'm rabbiting on again now, and I'm ever so sorry. But the thing is, you know, I've got a target audience, and who are they? Well, amateurs like me, and you know, there are some really technical people that watch my channel, and I get some really technical comments. That's fine. That's brilliant. You know, Blues Doctor, he's teaching me quite a lot. He talks to me quite a lot on a technical level, but some of it I understand, some of it I, you know, and some of it I don't understand, and I freely admit it. I don't care, you know. That's me. I'm honest, you know. So anyway, enough of that now. That was that video. The video you're going to see is well, it's something else really. I mean, the results were quite remarkable from this item that Blues Doctor asked me to try, and I did, and that's in the video. The only other thing is I get time to think quite a lot, and I have thoughts, you know. Quite often when I'm watching these batteries discharge, it's like watching paint dry, and quite often I ask myself questions, you know, as you do. I do it all the time, and one of the questions I asked myself earlier on today was, have you ever tested the resistivity of that powdered activated carbon that you're now using? That was the question I asked myself. So, sorry, I just heard a strange noise. So yeah, what did I do about that? Well, I tested it, didn't I? Sorry about that. That strange noise was someone calling me. Where was I? Oh, this activated carbon. So yeah, I tested it, and I'm glad I did, because in my kiln a few days ago I had a pot, and I put some of my activated carbon granules in that pot. I then put a smaller pot inside that big pot, which contained the substance that I wanted to carbonise. And for obvious reasons, I wanted a different atmosphere, put a lid on it and carbonised it. So I thought, okay, so let's have a look at those bigger carbon granules, the activated carbon granules. You know, the regular stuff that you use for the fish tank for filtering and stuff like that. You know, sort of 4 or 5 mil pieces. And I measured the resistance. And I measured the resistance of some that I've got up there in a tub that have never been anywhere else but in that tub since I bought it. And there was a difference on the resistance. Not a lot, but there was a difference. The stuff that hadn't been in my kiln, for instance, measured I think 1.2 ohms, and a comparable piece, you know, size wise, from this tub that went in the kiln was actually 0.9, 0.8 of an ohm. So I thought, I'm going to have to measure this powdered activated carbon that I've got, that I bought on eBay. And lo and behold, I'm glad I did, because the resistance of that stuff was 2.2, 2.4 ohms. Now this was on a pressure plate test. You know, the way I test all of these carbons, I measure it as it comes out of the kiln, if I can, and if not, I grind it up and I press it between 2 plates. You know, I've shown this before, and measure the resistance, and that's always lower, always. So, yeah, 2.2 ohms. So, I've got some in the kiln now, some of this powdered activated carbon, and I'll let you know what happens with that, whether we've lowered the resistance or not, because it's quite a poignant point, really. You know, I've been working with this activated carbon, and it's you know, on my anode, and it's working really, really well, as we know. But if it's 2.2 ohms, it's no good to me, is it, at the end of the day? So that's that bit. I'm just feeling my way through what I'm doing, and that is all I'm doing. So sorry if I've bored you again with this, but you know, it's that really mixed bag from that last video. You know, the way the comments are sort of, they've all been positive, I'll say that. You know, I'm not angry with anyone, and if someone can educate me, go ahead. I stand to be educated any day of the week with anything. Well, hopefully about batteries and battery components. So I'll leave it at that before I actually bore you to death, and let you see this other video of this new carbon that you haven't seen yet, and is just for you, Blues Doctor. One-off special. Okay, so as I said in that short introduction, this is a one-off special for Blues Doctor, who is subscribed to my channel and sounds like a very well educated man. And I actually said that a couple of times now. He's mentioned obviously about this garlic. We know what the onion does. We've seen the onion. We know the resistance. The garlic, which I said to him, I've already tried it,
and he said this morning, I think I must have missed the video. Well, I haven't put the video on yet, but garlic, 0.9 of an ohm, you know, almost the same as the onion. But the problem is I have got so much stuff to test that I haven't tested yet. There's potato there, look. There's corn knobs there, look, which is the actual corn that you eat, and the middle bit, I guess you'd call that the knob, I don't know. But you know, there's that. There's just so much stuff. Tea, I haven't tried that yet. We've got spring onion, I haven't tried that yet. There's just so many of them that I haven't tried, and combinations of them, you know. Because what I do is I'll take onion, test it on its own merits, garlic, test it on its own merits, and then try an addition, you know, and it just goes on and on and on and on and on. It's kind of a never-ending spiral. So there we are. That's a garlic clove, one of the garlic cloves, and I didn't want to disturb this battery, so I've just knocked up another one. It's on charge at the minute. I'm going to turn that off. It is, I think, just ever so slightly bigger than the surface area in there. Let's have a look. Yeah, it's about 5 mil. You know, bigger than this one, so that's that. But the main thing was, I wanted to show Blues Doctor this garlic. So here we go. Let's turn that on. That's the load, and that's the time. Now, like I say, I've only just set this up. You know, this is the first charge. I could have undercharged it, overcharged it, I don't know, I can't remember. I'm answering so many comments this morning, being Sunday, well, I say Sunday morning, it's actually Sunday afternoon. It is almost 1 o'clock PM, Sunday. There's the other clock, just to prove a point. So yeah, Blues Doctor, you can check the timing on this one. I did say I would make this one-off special just for you, and here I am. So I'm just going to shut up and let that run. I don't know whether I'm just going to time-lapse it or just do a start and an end, but one way or the other, this video will see the light of day. Well, at the moment we're doing quite well, because we've got a volt and we're on 6 minutes and 36. Well, so far then, for its first charge, this is now looking, dare I say it, every bit as good as any other result I've had, even with my own cobbled up, shall we say, or blended carbon. The one which I've now got 14.5 minutes from. So, you know, we've still got 0.6 of a volt there, almost 0.7, and we're almost on 12 minutes. Well, there you go then, Blues Doctor. I'll charge it again now. We'll reset that. That's quite interesting as well, to be honest, because that was fairly quick to get back up to there. So let's give it another charge and give it another run. I'll be back. Right, this will be run number 2. That's reset. That's on. Start that. So this is charge number 2 on the garlic, which is on the cathode there. Just garlic, nothing else. And I'm just going to let that run. Well, I've got to say that I'm ever so slightly gobsmacked at the moment, because we're still about where we were before, just over the volt there, and we're on, well, almost 8 minutes on this second run, so it's not looking bad. I'm even more gobsmacked now because we're on 9 minutes and we've still got a volt. And I was well, what I'm going to do, what I'm going to have to do now as well, obviously, is do a third charge. I was going to call it a day at that, but it's starting to look a little bit special, isn't it? Well, well, that's certainly on the money to beat my other carbon. I got 14 minutes 33 seconds, I think, from mine. You know, that carbon I spoke about that I'd put together, as in version 1, 2 and 3. I've got version 4 already, but haven't tested it yet. So let's see what it's got to beat. 15 minutes and still got 0.6 there, look. Okay, so that humble garlic clove carbon, which measured 0.9 of an ohm, has just done two minutes extra to my own carbon, the one that I was kind of bragging about a little bit, but as I suppose there's a couple of things I've got to say. That I did admit that the surface area on that was just ever so slightly bigger than, you know, the other surface area that I've got on the other battery, so we'd have to do a little bit of a compensation there. But even so, I think, you know, for its second charge, I would have to say that it's still done marginally better than my other carbon. Although, as I've said, I have not tested version 4 yet. But I'm quite astounded with this, really. You know, I couldn't grumble at that. So, I think I'd best give it another charge and come back. Right then, I need to be quick on this third run. We're still on 3.4 volts there. This is run or charge number 3 on this garlic carbon that I've got on this battery. Let's see how run number 3 does. I need to crack on a bit now because I've got a couple of videos to edit and upload to YouTube, including this one, of course. So this really will be the start and the finish. Okay, here we go. I have to plug my charger into this phone. I've kind of just come back in again at the halfway stage, if you like, on this, so I'll pause the video again and come back at the end and we'll see what the time is this time. Okay, we're at the 10-minute mark and we're on 0.85. What I'll do is I'll let this run now and I'll probably just time lapse it. Okay, 15.5 minutes this time. Now, that was probably me actually. I think I rushed the charge on this one because I need to get out and do some shopping, but just goes to show, doesn't it, you know, that there are some properties there. I'll catch you all later. So, who would have thought that then? Garlic. Although it was pointed out to me, I do need to research this a little bit now myself, but it was pointed out to me by Blues Doctor that garlic has got a high sulphur content, and I don't know, I'm kind of trying to piece this together in my mind now, of stuff I've read in the past about sulphur on cathodes playing a major part. How, why, where, I really can't remember, but I do believe it was possibly a magnesium battery and solid state work. So I'll have a little look at it, and obviously you know, I've got to look at garlic again, haven't I? You know, I can't just leave it at that now. So I hope that was of interest, you know. Better times, look, you know, it's creeping up, isn't it? You know, bit by bit, trying different materials, and that's the name of the game at the end of the day. That's what I'm trying to achieve, is I'm trying to find the best of the best carbon of what I call a number 2 carbon, you know, the carbons that are going to be cheap to produce, or, you know, from waste, a waste material. What could be better than to find a really good carbon
you know, from a waste material. What could be better than that? I mean, come on, we know, you know, my #1 carbons are, you know, let's say graphene, but we know we're never going to achieve that level, but let's get as close as we can. That's what I say. Over and out.